We're doing something called rate of change. So what is rate of change? This is just a fancy word for the slope. Okay, it's just simply slope, but now it's like the applications of slope. For example, let's say there's a car, okay? It's driven, right? It's driven, let's say some easy numbers, 100 kilometers in, I don't know, like 5 hours, right? What's the speed? If you want to graph, it looks like this. On the y-axis, we have kilometer. So he went from 0 to 100 in 5 hours. So this is his graph. What is the slope of this? No? What's the rise here from 0 to 100? It's 100, right? What's the run?
5.
5. So the slope is 20. Now, if you put the units, see on the y-axis we had kilometers. So on the rise we have kilometers. On the x-axis we have time, which is in hours, so kilometers per hour. There you go. Kilometers per hour is the unit here. So this is the slope. Now, what does the slope represent in this case? Well, it represents speed. So the car was traveling at 20 kilometers per hour.
Okay.
Okay, so that's the rate. So in other words, the rate of change of the car was 20 kilometers per hour. Rate of change is simply the slope. Well, when we think of slopes, for a straight line, it's pretty straightforward. It's always going to be consistent. The slope does not change for a straight line. But when we get to curves, it's going to be different. So now let's look at this. Let's say instead of the car traveling in a straight line, the car travels like this, right? In a curve. This is the graph of y equals x squared. Here's the origin, and let's say the same idea here, 5. And on the y-axis, we have kilometers. Let's say he did 100 kilometers in 5 hours. So we're going to put a point here. What is going to be this slope? Is it going to be any different? What do you think? Will this slope be any different than the last one? What is the rise from 0 to 100?
100.
100, right? What's the run from 0 to 5?
5.
5. So the slope is going to be the same, right? Slope is going to be the same. So this is a slope between 2 points. And this is called the average slope or the average rate of change. Okay? And this applies, I mean, for a straight line, the slope is the same, so it doesn't matter the linear. This is for functions more than x, like x squared and whatnot. That's 1. And you see the straight line that we drew? This has a name. It's not that important, but this is called a secant line. So that's one way of finding the speed or the rate of change of a thing, of a function that is not linear. But then there's another thing that we can do. Instead of finding the average speed throughout this trip, what we could find is what is his speed at exactly 5 hours. So we want to find his speed, right? At exactly 5, not from 0 to 5, at exactly 5 hours. Then what do we do? In that case, you're going to have to draw something called a tangent line. A tangent line is a line that just kind of just touches the graph at 5, like that. And then you go about finding the slope of the tangent line. And this will give you the speed at that exact point. And this has a name. This is not average rate of change. Average rate of change would be this one between 2 points. This one is called a instantaneous. You know what that word means?
No.
Instantaneous just means at that specific time. Yeah,
Okay.
at a very, like, for example, at 5 hours, 15 minutes, and 15 seconds, what is his speed? So we will say his instantaneous speed at that time is yada yada. Okay, so 2 types. We can either have an average rate of change, an average slope, or we can have an instantaneous rate of change, an instantaneous slope at a specific point. average rate of change uses two different points, and it's just rise over run for both of them. But average rate of change uses two different points, whereas instantaneous rate of change uses 1 point. Let's look at some questions. So a pebble is dropped from a cliff 80 meters high. All right, so there's a cliff somewhere. Let's say this is the cliff, and the height of this is 80 meters at the top. So you don't want to be taking a shortcut down. And we drop a pebble, and it, I mean, probably drops like this. Someone tossed a pebble, let's say like that. And the equation of this line, right, is 80. It's given up there. It's S of t, which is just another way of saying y, S of t. This is the function notation, 80 minus 5t squared. What we can do is we can actually make a better graph. This is just a real life graph. It doesn't really help us that much. We're going to translate this into something that we can work with. Look at the function. What kind of function do we have here? No? Is it linear?
No.
It is not linear. You see t squared, that just means like x squared. It's a quadratic, okay? It's a quadratic, it's x squared.
Okay.
And it has a y-intercept of 80 right there. And then it's opening downwards 5, right? So it looks like this. The graph of that looks something like this. Over here, we can kind of find the intercepts if you want the x-intercepts. How do you solve this equation for t?
Add 80.
Add 80 won't help you. Try again. Subtract 80.
Oh, subtract.
So negative 80 equals minus 5t squared. What's next?
Divide by negative 5.
Yeah. So t squared is 16. What does that mean for t?
It's 4.
It's 4, but it is also minus 4. The square root of any number is plus minus. So that means this x-intercept here is minus 4. This x-intercept is here is 4. So after how long does the pebble hit the ground? You see this? Right here, pebble hits the ground. How long has it been?
4 seconds.
4 seconds. After 4 seconds, the pebble hits the ground. And that's basically the idea behind this question. What are they asking though? They're asking, calculate the average velocity of the pebble. So the average speed, right? So we're gonna pick 2 points and we're gonna find the slope of that line between t equals 1 and t equals 3. So let's say 1 is here. When the x value is 1, let's say 3 is here, like that. 1 is here, 3 is here. You see this? We're gonna try and find the slope of that line, and that's gonna give us the answer to part A. We're basically finding the slope, but it's kind of hard to see from the graph what's the rise and what's the run. So we're going to use a little formula here. The average rate of change is rise over run between those 2 points. The rise is y2 minus y1, if you remember. But when we're doing it in function notation, it's going to look like this. Your initial starting point is A, your ending point is B, and the formula for slope is going to be S of B, whatever the function is, minus S of A all over B minus A, where B is 4 and A is 0, okay? So now what does this even mean? Well, it's actually pretty straightforward. Let's first find S of B, which means S of 4. So if our function is 80 minus 5t squared, that's our S of t, right? We want to find the S. S basically means the height. We want to find the height when the time is 4 seconds. What do we do? Actually, it was not, B is not 4 because we're trying to do part A. A is 1, B is 3 because we're doing this question. So we're trying to find the height when the time is 3 seconds. we're gonna simply plug 3 into the equation. So it's gonna be 80 minus 5 times 3 squared, like that. 9 times 5 is 45, so this will be 35 meters. You see that?
Mm-hmm.
Similarly, we need to find S of 1. Can you tell me what S of 1 would be?
80 minus 5 times 1 squared.
Yep. So that's just going to be 75. Alrighty. Now look at this. It's very straightforward. So it's going to be S of B. Well, S of B for us is 3, right? S of B. This is S of A. It's always going to be the upper number minus the lower number. So here it's going to be 35 is S of B minus our smaller number that we got. S of A was 75. All over B. B is 3 minus 1, like that. So this is negative 40 over 2. So it's negative 20. What does this tell you?
It's the slope.
Yeah, but in the context of the question, what does this tell us? It is the slope, yeah, but if you were to saying it, the way I like to think of it is like, try explaining it to someone who doesn't really know maths, like your boss or something, I don't know, like your brother or your goofy friend, whatever. Look at it, it's given in the question. Velocity just means speed, right? So what this number tells us is that between 1 and 3 seconds, the pebble was dropping at a speed of 20 meters per second. Okay? So this is the speed of the pebble in that time period. And that's the whole question. B is also similar. Now instead of the upper bound being 3 seconds, the upper bound is 1.5 seconds. So we can quickly find out the upper bound, S of 1.5. So that'll be 80 minus 1.5 times 1.5 squared. 80 minus 5 times 1.5 squared. That gives me 68.75. So for B, we're trying to find the average rate of change between S of 1.5 minus S of 1, right? Always going to be lower bound, sorry, the upper bound minus the lower bound. S of 1.5 is 68.75. What's S of 1? We have it here. We found it in part A.
75.
Yeah, 75 divided by 0.5. So 68.75 minus 75 divided by 0.5. It gives me minus 12.5. So what does that mean? Minus 12.5.
It's the average speed.
Yeah, between 1 and 1.5 seconds, the pebble was dropping at an average speed of 12.5 meters per second. Okay, so that's the pebble's speed at that time period. Part C is asking us, why is the answer to part A and the answer to part B, why are these different?
Because there's different times.
Yeah, there's different times, and it's also because it's not a straight line. So if you look at that graph in more detailed, in like this, like let's say we just like this. Look at it between 1, it's gonna peak at right there. It's gonna peak right there. Between 1 and 1.5, the slope is like this, right? The more steeper the slope, the more vertical the slope, the higher its value. And then between 1 and 3, like 1 and 3, it looks to be a little bit more steeper, right? So that means it's faster here than here. But the answer to part C is because it's not a straight line, it's a curve, and the speed is the tangent line or the secant line is going to be different depending on which 2 points you picked. Like if you picked a point from here to here, the speed is 0.
Mm-hmm.
So that's the average speed. All right, so now this is going to be a little bit more difficult. Now this question's asking us the speed or the velocity. Did they tell you what the difference is between velocity and speed?
I think so.
They're basically the same thing. Velocity is something called a vector. It has a number and it has a direction. It has a value. By number, I mean it has some value and it has a direction. Speed doesn't have a direction. It's just a vector. Oh, sorry, it's just a scalar. It's not a vector at all. It's just a scalar. It does not have a direction. It just has a certain value. So if you say the car is traveling 2 kilometers per hour, that's going to be its speed. But if you specify its direction, like the car is traveling 2 kilometers per hour north, that would be its velocity. A very slight difference. For us, it doesn't matter. We don't care about that here, but we can replace velocity with speed. If we do, I guess when you do physics, then the difference matters. But here we're doing maths, not that big of a deal. Now look at this. What is the velocity of the rocket at t equals 4? What are they asking us? What do you
The
think they're
speed
asking?
at 4 seconds.
The speed at exactly 4 seconds, right?
Mm-hmm.
So now we're not looking for the slope of a secant line. We're looking for a slope of a tangent line. How do we do that? I could show you the long way of doing it, which is how the book does it. Let's do one of these questions the long way. Now there is a formula for IROC, which means the instantaneous rate of change. AROC is what we did before. That's just f of b minus f of a over b minus a. It just means this is just a fancy way of saying y2 minus y1 over x2 minus x1 in function notation. There is a formula for IROC as well, which is a little bit more complicated. Looks like this. IROC is equals to the limit as h approaches 0 of f of x plus h minus f of x over h. Now this thing, limit this thing, what does this mean? It just means the h you see on the bottom, it's going to 0, but it's not exactly 0. Okay, you can even ignore this if you would like. I'm just going to put it there just for reference. So to do it this way, to find the IROC, h is 0. You can ignore h. What we need is we first need f of x. What's the x value in this question?
4.
4. So we need f of 4, but the function is called s, so let's call it s of 4. How do we find s of 4?
Do you plug in x is 4?
Yeah, you want to try it? Do you have a calculator?
Mm-hmm.
Try it and be careful. The negative 5, yeah, you tell me what you get and I'll tell you if you did it right or not.
I got 42.
That's right. So S of 4 is 42. This just means when the x value and the time is 4 seconds, the height or whatever this is 42 meters. Now the next part is going to be the most difficult part about this problem. We need to find f of x plus h, which in the context of this question is S of 4 plus H. The H is 0, but we can't ditch it yet. Okay? So how do we do this? Well, what you're going to do is wherever you see a T, you're going to replace that with what you see in the bracket. Like for S of 4, you replaced all the T's with a 4, right? If I asked you for S of 5, you'd replace all the T's with a 5. So now we're asking for S of 4 plus H. So what you need to do is replace all those T's with a 4 plus H. Like this. So T squared becomes 4 plus H squared. The other T becomes 4 plus H and plus 2, like this. Okay? Replace all the T's, and this applies to anything. For example, if I asked you what's sine of x plus log x over ex squared or something, you'll literally replace all the T's with that bracket. So 5t squared plus 30, that bracket plus 2. So it doesn't always have to be numbers. Could be like something like this, x plus h. Now we need to simplify this bracket. What do? We need to clean this up. You want to open all the brackets. The second bracket is pretty simple, actually. It's just 30 times 4, 120, plus 30 times h is 30h, and then you have a plus 2 here. How do we go about opening the first bracket?
Do you apply the exponent first?
Yes, you do. Definitely bad math says exponent first. So what does that give us if we were to do that?
Negative 5 times 16 plus h squared.
All right, so that is yada yada boom wrong. I'm gonna show you why that's wrong. You're on the right path, but this is again a very common mistake. So when you have something like a squared plus b, a plus b whole squared, this is not equals to a squared plus b squared. You're missing a term here. Let me show you. 2 plus 3 squared is 5 squared, 25, right? But then if you rewrite this as 2 squared plus 3 squared, you get 9 plus 4, you get 13. You're missing a middle guy here, right? You see? So 4 plus h whole squared is not 16 plus h squared. There's something else in there. I'm going to show you. And maybe this will help. It comes from this, okay? 4 plus h, this is old school way of doing it. By old school, I mean the complete way of doing it. But we're not going to do it like this, at least not for something whole squared. You want to go like this. You're going to foil it. This is called foiling. First, this is, you've done biology, haven't you? You've done like genome sequences, the little tree that we have, like RR. You know what I'm talking about? The traits
Like
that are
this.
yeah.
Oh,
Yeah, this is exactly like that. So you're gonna do
like the
first,
Punnett square.
yeah, exactly, Punnett squared. So this is the same idea here. So you have 4 plus, we can even write it like this, which is really goofy, but we have those two up there, right? We have those two. So 4, 4, 16, 4, 4, 4h, right? h4, 4h, h 8 squared. So you actually get h squared, and then the like terms 4h and 4h is 8h plus 16, like that. Okay. So we're missing the 8h there in the middle. If you would like to know, there's a formula for this. A plus B, very useful. If you have something plus something whole squared, it's going to be a squared plus 2ab plus b squared. For example, if you have like 8 plus a squared, the first term is going to be the a squared, so a is 8, it's going to be 64. Let's call this x. The next term is going to be 2 times the first term times the second term, and the last term is going to be last term squared. So you're missing the middle term when you just open it like the way you did.
Okay.
So now what? Let's open this bracket.
Negative 5h squared.
What else?
Plus 80 times h.
Minus 40h minus 80 plus 120 plus 30h plus 2. Now we're going to clean this up so you get minus 5h squared, yeah? What else we got the like terms? We got minus 40h and plus 30h. That's going to be minus 10h. And 120 minus 80 is 40 plus 2 is plus 42. And there we go. And that's the thing. Cool.
Okay.
Now we're going to plug everything in here. Now that we have everything that we need. It is going to be the limit as h approaches 0, right? What is f of x plus h? We just found it. This is s of 4 plus h for us. It's going to be minus 5h squared minus 10h plus 42, okay? Minus, what's f of x? F of x for this question is just s of 4. It's minus 42, right? All over h, like that. Now look at this, plus 42 and minus 42 cancels out. Whenever you do this question, whenever you're trying to find IROC, something will always cancel out.
Okay.
Now look at this, the remaining terms on the numerator, what can you pull out?
Negative 5h.
Yeah, what are you left with if you pluck out a negative 5h?
Negative 5h minus 2h.
No. No. So when you're plugging out negative 5h, you're just dividing it, right? So look at this. We had negative 5h squared. We plucked out negative 5. This cancels out with the negative 5, right? And then the h cancels with the squared. So you're just left with an h for the first term. For the second term, we had negative 10h. We're taking out negative 5h. Yeah, look at this. The h and the h, boom, but I'm gone. And 10 over negative 5 is positive 2. Okay.
Oh, okay.
Now, the h, this is the main goal. When we're doing AROC, we need to cancel out that h in the denominator that we start off with. This h cancels out with this h. And if there's any more h's remaining, they're going to become zeros. We need to cancel this h first before plucking h as zeros, because otherwise we'll be dividing by a 0. So now the h's are canceled. It's going to be limit as h approaches 0 of negative 5, 0 plus 2. Actually, you don't have to write the limit anymore. Now we just plug the h as 0. So this will be negative 10. And then there you go. And that's the answer.
Okay.
Made sense? A little bit tricky though, right? Okay, we're gonna try and do this a different way, which is the way that we're gonna be doing it moving forward. I mean, this is really good practice for algebra though. The math here is not difficult, it's just opening a lot of brackets and making sure that you do things right. It's about grade 9 level math. I'm gonna show you something that they're not gonna teach you just yet. Instead of doing this whole mumbo jumbo IROC formula, what you could do is you're gonna use something called the derivative. Now, what in the world is this? Well, this is simply the slope function. This will straight up give you the instantaneous slope function. So you don't have to do any of this formula mumbo jumbo. So how does this work? Let's look at the equation. We have s of t. So when you find its derivative, it's going to become s prime of t. Okay? It's a one-step answer. That's why this is so much stronger. That is going to be equals to. Now, how do you find the derivative of a function, right? I'm going to give you 20 examples here. If it's a number like plus 3, its derivative is going to be 0. Any number, doesn't matter, plus 3, even pi is a number, right? Minus pi or minus pi to the power of 10. See, all of these guys are constants. Constants, the derivative is going to be 0, okay? So 2 becomes a 0, you can ignore the 2. Now, if you have something like 30t, right? 30t, like 30t or like even like 40x, negative 50x, the letter drops. So the derivative of 30t, you just drop the letter. It's gonna be a 30, okay? Constants become 0, you can just straight up drop the constants. If it's something with x to the power of 1 or t to the power of 1 in this case, the letter drops, but the number stays. And then finally, this is gonna be the most important part. If you have something in the form of this, a times x to the power of n, like for example, maybe 3x4, yeah?
Mm-hmm.
What's going to happen is that the power is going to come down here, like for logs it does, right? The power is going to straight up, we don't need to use log, it's going to come down here straight up. And then once the power comes down, you're going to subtract 1 from the power. So for this example, it's going to look like 4 times 3 times x, and then the power becomes cubed. So this becomes 12x cubed. The derivative of 3x to the 4 is 12x cubed. You see that?
Mm-hmm.
Using this logic, right? So if you started off with axn, this is going to become n times a times x to the power of n minus 1. This is the general rubric, but you don't have to remember any of these formulas. You can just use logic. Would you be able to tell me what's the derivative of negative 5t squared?
Two times -5t.
Yeah, so that's gonna be negative 10t, right? Straight up.
Mm-hmm.
And what's the importance of this? Well, once you have the derivative slope functions, you can just straight up plug 4 in there. Whatever the x value is, you straight up plug that in there. So let's do that. So negative 10 times 4 plus 30, it'll be negative 40 plus 30. It's negative 10, you see? It's super quick. You don't have to do all the limit, all this junk.
So why do we learn that junk?
I don't know, because that's the way they teach you. Look at this right here. I guess you need to know where it comes from. That's the idea.
Okay.
No one uses this, by the way. No one in the world is using this to do these things. But it's just the way that they start off with this. Okay? And it's
Mm-hmm.
also good algebra practice, so we're gonna do it both ways. Just because we can. Oof. This one is going to be a lot more trickier. It's the same question. I'll tell you what they want. They've given you a cost function. And x is the quantity, right?
Mm-hmm.
And this is C of x is the money that it takes to produce x numbers of calculators. Part A is simple. It just says what's the cost or what's the y value when the x value is 100. You see A?
Mm-hmm.
What's the y value? So how do we do this? How do we do part A?
You just plug in 100 as x.
You literally just do that. So it's going to be 10 times the square root of 100 is just a 10 plus 1,000. So it's going to be $1,100. Okay.
Mm-hmm.
B, what is the rate of change when x is 100? So is this average rate of change or instantaneous rate of change?
Average.
It's average. What are the 2 points? Average uses 2 different points, right? Like from 2 seconds to 5 seconds or something. It is not average, it's instantaneous because they've only given you one specific point. X is 100. Okay?
Mm-hmm.
So now if we use our derivative thing, and I'm going to show you how to do the long way as well because it's important, because over here we're going to need to rationalize the numerator. If we use our derivative thing, our thing kind of flops because the formula was this. Ax to the n was n times a times x to the n minus 1.
Mm-hmm.
What's the power of x here?
1.
It is not 1. No. Square root of 2. If it's square root of 2, what does that mean in terms of power? It is not 1. Square root means, right, there's an invisible 2 here. So that's going to come in the denominator. Square root of 2 means it's x to the power of 1/2. Remember that?
Oh, okay.
Cube root is x to the power of 1/3. So our actual function, again, the 1,000, the derivative of 1,000 is a 0. So c prime of x, the 1,000 is gone. We drop it. But now let's look at 10 to the power of x 1/2. This is in this form. So we can definitely use this formula. So what's going to happen is that the exponent is going to come down, and then we're going to deduct 1 from the exponent. So it's going to become 1/2 times 10 times x to the power of, what's 1/2 minus 1? 1/2 minus 1.
Negative 1.5.
Negative 0.5, not negative 1.5. 1/2 minus 1. It's half minus 1, negative half. You can use a calculator if you want. 1/2 minus 1 is 1/2 minus 2/2. So it's negative 1/2.
Okay.
Now let's simplify this. So 1/2 times 10. What's 1/2 times 10?
10/2.
Yeah,
So
which is a
5.
5. And we do not like negative exponents. You see x to the power negative 1/2? No go. No good. What we're going to do whenever you see a negative exponent, you're going to toss it into the denominator or the numerator. You remember that? You can toss it up or down. Like for example, if you had 1/x to the negative 1/2, you toss it up, it's going to become positive 1/2. Similarly, if it's already in the numerator, we're going to toss it in the denominator. Becomes like that, right? And then we can just rewrite this as square root of x. There we go. Cool. So the derivative of c of x, the cost function, is 5 over square root of x, like that. That's going to give us the instantaneous, whatever they want, rate of change at any x value. Look at part B. They want the instantaneous. We know it's instantaneous because they've only given us one specific point. So we simply plug 100 in there. So you get 5 over square root of 100. It's 5 over 10. It's 0.5, okay? So the answer to part B is 0.5. What does that mean, though? In the context of this problem, how would you describe that? So if you look at the question, again, IROC is also the slope. It's also rise over run. On the rise, on the y value, we have dollars, right? So $0.5, our slope is going to be rise in the numerator of the unit. And on the denominator, we have the number of calculators. So when you're producing 100 calculators, right, the rate of change per calculator is $0.5 per calculator. So it's going to cost you $0.5 per calculator at 100 when x is 100. Okay? So this way, very quick. Now we're going to also, unfortunately, have to do it the old school way because they're going to ask you to use this formula here to find the answer. So the formula, let me just pull that in. This is what we did before. Just going to leave this on the side. So our x value is 100, right? So we need to first find f of a, which means a is 100 here. A is just the x value. So we need to find c of 100, right? What's c of 100? Well, we already found it in part A. It is 1100. Okay. Now we need to find f of a plus h, which is going to be c of what? Well, a is 100, right? H is h. So c of 100 plus h. Can you tell me what that is? C of 100 plus h. No? So you see, wherever you see an x, you're going to replace that with what's in the bracket. So right now in our bracket, we have 100 plus
what
h.
do you do with the h?
You just leave there as h. H is 0 technically, but we're going to be dividing by h here, so it's an arbitrary h.
Okay.
Cool? And
Mhm.
now look at this. Now we're going to set it up. Limit as h goes to 0, f of a plus h, which for us is 100. There's also a plus 1,000 here, right? Like that.
Mhm.
We do this. Yeah, we're good. So 100 times, or sorry, 10, it's not 100. 10 is on the outside. 10, so 10 of 100 plus h. So that's this bit here, plus 8,000, minus, what's f of a? What's f of 100? Or c of 100? It's 1100, right?
Mhm.
All over h. Now plus 100 and minus 1100, that's just a minus 100. Now the question is, what do you do next? What do you think? Because the h's are not canceling out right now. You need to rationalize the numerator. What's the conjugate of the numerator that we have right now? So the conjugate, right? Look at this. If it was just 10 times 100 plus h, it'll be itself, right? It'll be itself. But the fact that there's a minus 100 in there, so that means the conjugate will be the same thing except with a plus 100 in the middle, because we're going to need to use the difference of squares, okay?
Mhm.
Plus 100 there, and whatever you multiply the numerator with, the conjugate, you also need to multiply the denominator with that guy. Like this. On the bottom, we don't care, because it's going to cancel. Once this h cancels out, it'll be very easy to work with. So on the denominator, it's just going to be h times that entire thing. But what do we get on the numerator? Look at this. A, right? We have a here. A times a. A minus b times a plus b. It is going to be a squared, right? Difference of squares. A squared minus b squared. See, like that?
Uh-huh.
100 squared is 10,000. So minus 10,000. I'll just write it right there, actually. What about the other bracket? If we open that squared, what do we get? Can even do that on the side. So we have 10 times 100 plus h squared, right? Remember, this squared applies to everything inside. So it's going to apply to the 10, and it is also going to apply to the square root. So that means 10 squared is 100, right? What's the square root squared? It's going to be nada, right? They cancel out. The square root and the squared, they cancel each other out. They're the inverses of each other. You see that?
Okay.
So then we have 100 times 100, which is 10,000. It's 10,000. And then we have 100 times h, which is 100h, right?
Mhm.
Like that. Good so far?
Uh-huh.
Now look at this. 10,000, 10,000 gone. Thank God. So that part is gone. And now we're only left with 100h on the top, right? And now check this out. H and h cancels out. And now that the h is canceled out, now we can plug everything else. If there's any more h's, those will be zeros. So the only h is this guy down here. So we get 100 over 10 times the square root of 100 plus 0 plus 100. You see that?
Mhm.
That's 100 over 10 times the square root of 100 is just 10 times 10. That's 100 plus 100. So you get 100 over 200, which is 0.5, and which is what we had before.
Okay.
Do you like this method?
It's okay.
Yeah, just like very weird and challenging in the beginning. But trust me, the other way we're doing it, right?
Mm-hmm.
That thing is gonna completely bomb when you get something like this. Maybe that's why they're teaching this to us. When you have sine of x. This thing only applies to polynomials. See that?
Uh-huh.
When you have something like sine of x, that is not a polynomial. Polynomial is something like x squared. Even if this was sine of x squared, this is not a polynomial. This is a trig function. So that rule fails here. You want to know
Mm-hmm.
what's the derivative of sine x?
What is it?
It's cosine x. Boom, boom. Cosine x is sine x with a minus sign. We'll get to this later, trig functions. We always start with polynomials because the rule is very simple. These guys, the way they found it was by using this formula right here. And it's trickier than it looks. We're not going to worry about that for a while, but there you go. That's IROC and AROC, okay?
Mm-hmm.
Let's actually look at this question. Give a geometric interpretation of this guy here.
How do you do that?
We got to work backwards. And it's definitely, yeah, this one is weird. The answer is just two steps, but like if you don't see it, you don't see it. Ignore the h's, right? Kill the h's because we kind of introduced the h. What if I told you f of x was square root of x minus 2? So that means, look at this. F of 4 plus h, right, is going to be square root of 4 plus h minus 2. And the h in the denominator is when you do the formula thingamajig. So now, yeah, basically you need to come up, using this, you need to come up with this. Drop the h's, okay?
Uh-huh.
And whatever's in there is probably root x. So now what does that mean though? It means, let's say we have this square root function going 2 units down. So it's going to look like this. This is our f of x, root of x
Mm-hmm.
minus 2. This is our function. And this means the instantaneous slope when the x value is 4, like that. So this means the slope of the tangent line when x is 4. Okay?
Mm-hmm.
It's weird, isn't it?
A little.
Don't worry too much about this. That was just a trick question. This one is better though, because they give you a graph to begin with. All right. Again, remember this. The steeper the slope, like this, the greater the slope number, okay? The higher the slope, basically. The steeper it is, the more vertical it is, the higher the slope. And if it's flat like this, that means the slope is 0. This means the slope is 0. If it's vertical, it means the slope is infinity. It'll never be vertical. I mean, actually, it will be vertical. Like, for example, when x is, what's the graph of x equals 4 look like? Where it looks like this. There's a straight line that goes through when x value is 4. The slope of this line is vertical, is infinite. Because you'll be dividing by 0. But that doesn't apply to this question, though. Between which two consecutive points is the average rate of change in the function the greatest? So we're looking for the most steepest slope, right? You can only use the 5 letters that they've given you. We can check one by one. Look at this, d to e. What's the slope? It's horizontal. What does that mean? If the slope is horizontal, right? Slope is nada, it's 0. Okay.
Mm-hmm.
Slope horizontal means slope is zero. If it's a horizontal average line like this one, its slope is going to be zero. If it's vertical, it's infinite. So D to E is out. That has a slope of zero. We want the greatest. So now it's going to be between C and D, A and B, right?
Mm-hmm.
Which one is steeper? Is there a way to find this? They're equal, actually. But they want the greatest, right? C to D will have a negative slope. So let's assume, you can just, there's no axis here. There's no numbers on the axis. So we won't know what the slope is for sure. But C to D, let's say it's -2. That means A to B is going to be +2, right?
Mm-hmm.
So it's because they want the greatest. I think 2 is greater than -2. So it's going to be between A and B. That's going to have the greatest rate of change. The slope of the
Okay.
secant line is going to be greatest between A and B. Part B, is the average rate of change between A and B greater than or less than B? Well, it's greater than, well, actually, no, they're asking us a different question. So for B, they want the average rate of change from A to B, right? You see this line, which looks like this. Is this greater than or less than the instantaneous rate of change, which looks like this? What do you think? Which one has a steeper slope?
A to B.
Yeah, A to B definitely has a steeper slope. So when you go towards a turning point, like at B, it's close to a turning point, it's getting flatter and flatter and flatter, and it's going to eventually have a slope of 0. So A to B has a
Mm-hmm.
greater slope than the instantaneous at B. C, sketch a tangent to the graph somewhere between D and E, where the slope of the tangent is the same as the average rate of change between B and C. So the average rate of change between B and C is this. It's horizontal, right? Slope is 0. Now they want us to sketch a tangent. That means we need a horizontal slope somewhere. Not there, not there, not there, not there, not there. Horizontal slope is always strictly at a turning point. So it must be there. The slope there at the turning point is 0. And that's the answer to that question.
Okay.
Okay, look at question 5. What is wrong with this statement? The speed of the cheetah was 65 kilometers per hour north.
That's velocity.
Yeah, exactly. Why is it velocity?
Because there's a direction.
Right. Read number 6. Is there anything wrong with this statement?
That's just speed, not velocity.
Yeah, exactly. So that's a cute little difference between speed and velocity, right?
Mm-hmm.
Here's the funny thing about vectors. Let's say you're starting here at 0, and then you travel 5 kilometers somewhere to point A. You travel like 3 kilometers somewhere to point B, and then you come back home to point C, right? Let's say this is 4 kilometers. What's the total distance you've traveled?
12 kilometers.
12 kilometers is your distance, right? Now
Mm-hmm.
there is a distance this is a scalar. Distance is a scalar unit. Now what's the vector equivalent? Like speed is a scalar, it's a velocity, right? The vector equivalent of distance is something called a displacement, which doesn't care about the route you took. It only cares about where you started and where you ended up. What do you think the displacement is in this case? Did the guy actually move? He started at C, he went around town, and then he came right back to C, right? Displacement is the final position minus the initial position. He didn't move. According to displacement, he did not move. Displacement is 0.
Mm-hmm.
that means velocity is also going to be 0 because velocity is displacement over time. Whereas speed is distance over time, right? And the notation for displacement, you just got to put this little arrow on top. So d with an arrow means displacement, whereas d by itself means distance. So for this person, he had 0 displacement, he had 0 velocity, and if you really want to go down this rabbit hole, this person also did something called 0 work. Work is the energy you spent, because work depends on displacement. It gets a little bit weird when you're talking about vectors, because the route doesn't matter. What matters is where you started, where you ended up, ultimately. Anyways. All right, let's call it a day for there today.
Okay, thank you.
See ya.